All right, for our first transformation, we call it a translation or shifting of points. And we have this triangle here, triangle 1, O, and E. And we're going to translate each of these points and move the location of this triangle. To do that, we're going to move to the right. We'll choose point N first. 1, 2, 3, 4, 5, 6, 7. And then down 1, 2, 3, 4. We'll call that point now N prime. Then we're going to use the point E, do the same thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Place a point, call that E prime. Last point, starting at its original place. 1, 2, 3, 4, 5, 6, 7. And then down 4, 1, 2, 3, and 4. We'll call that point O prime. Connect your points. Hopefully you still have a triangle. And as you can see, we've translated triangle ONE to its new location. The structure that we have there is we move to the right 7 units, and we move down 4 units. If we use algebraic notation, this is what we do. We say that all points, generalizing it, that's x, y. Arrow means that we're going to apply transformation. And what that would look like is right 7 units means that the x value, which we move left or right with x, we move horizontally, is going to move in the positive direction 7 units. When moving right is positive. So you can probably guess what now I'm going to say for the y coordinate. The y coordinate is moving down or up. In this case, we're moving down, and when we're moving down, that's subtracting or losing value. So that's going to be y minus 4. So all points, this will be the translation in an algebraic representation. This, of course, are words, and here is our picture. Multiple representations. So we call this translation by shifting. We're shifting horizontally, and we're shifting vertically. Simple enough. Give it a shot. Our second construction. This is called reflection over the x-axis. As you can see here, I have my axis labeled. Reflecting is to kind of mirror over. I have visualized that this triangle TWO or triangle 2, is going to flip over. So some people say, like to call it, it's a flip over the x-axis. We like to call it a reflection. So to do that, this is what we can do. If you look at the point T, it's moving 3 units away from the x-axis, so when it flips over, it's going to be 3 units below it. I'll call that T prime. If you look at W, 2, 4, 6, 8, 9 points, 2, 4, 6, 8, 9 points, oh boy, move the whole way down here. And then we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 6. So we'll call this W prime, we'll call this O prime. And again, get your straight edge. Connect. Sorry about that black line there. I think you can figure out what to do. And if you notice, we get this reflection across the x-axis. The shape has not changed, it's just changed its location. So if we think about what took place, we need to figure out a way to represent that numerically. So when we say we reflect over the x-axis, it's hard to write that like we did last time and saying we're moving right, we're moving left when we have a flip. So the notation algebraically is that all points, if we take a look here, if you notice that T, they have the same x value, but if you look at the y value, this is 3, but this is negative 3. Interesting. If you look at the W's, W and W prime, they still have the same x value, but now their y values are opposite each other. If you look at the O's, they again still have the same x value, but the y values are opposite each other. So if we think about that, the x value doesn't change. It's the y value that changes. The notation we use is negative, or the opposite of y. It's the opposite. Take the opposite of y. So all these y values are positive, so now they're all negative. But if we had some negative y values, they would flip up and become positive. Okay? Give that a shot. Let's move to our final one for part 1. This time we're reflecting over the y-axis. We're reflecting across this way. So when we look at triangle tray, TRE, we're going to see a reflection across the y-axis. So let's apply a similar approach that we use for reflecting across the x-axis. Let's look at point T. If it reflects over the y-axis, it'll reflect by 1, 2, 3, 4, 5, 6 units. So I go 6 units to the right now. 1, 2, 3, 4, 5, 6. Place a mark, we'll call that T prime. If we look at R is 4 units away. It reflects across 4 units to the right. We'll call that R prime. However, this time, E is already on the right-hand side, so when it reflects, it actually reflects back over across this way, 1 unit. Call that E prime. So there's a slight overlap, but you can still see that we properly reflected triangle tray over the y-axis. You have a nice symmetrical picture there. So, again, we are reflecting the object over the y-axis. So it's hard to write that in terms of words, except to say that we're flipping over the y-axis. But algebraic notation says that all points have the following transformation. If you look, this time the y value doesn't change. If you look at the y value here, that's 3 units. That's also 3 units. But this is negative 6. This is positive 6. Point E, 1, 5. This is now negative 1, 5. Again, the y value didn't change, but the x value changed. Lastly, same thing happens with R. The y value doesn't change, but the x value does. And it changes by simple sign change. So we get negative x equals y. So in that explanation, we have then that we're taking the opposite of x, but we're leaving y alone. So if you notice, any negative x values became positive, any positive x values became negative. So this is what we call reflection over the y-axis. We're going to pause, and we're going to have closure on this part. There's another video for you to watch. Enjoy.